Okay, hi everybody. Well, it's great to be here today. My name's Georgina Kyriakoudis, and I'm representing the University of Nicosia to tell you about how and why we've put academic credentials onto the blockchain. So we all rely on our academic credentials to prove the expertise, the knowledge which we've gained having been at university, having trained. And we go to employers and we show them these academic credentials, and they rely on this to know whether we can do the job we have. Unfortunately, it's extremely easy to fake an academic credential. It's normally a piece of paper, a PDF document, and hence it's become big business around the world, having companies which specialize in creating fake academic certificates. In fact, there are over 2,600 companies worldwide doing exactly this. One company in Pakistan was recently closed down. In 2015, they created 215,000 fake academic certificates and made a profit, in fact, a revenue of over 50 million. And these certificates weren't just going to people in Pakistan, there were people purchasing from all around the world. Research into this found that in the national health system in the UK, there were nurses with fake certificates, consultants, psychologists. One example was a consultant in pediatric emergencies who had a fake healthcare technology diploma. Another example, in the Philippines, you can buy for between $30,000 and $50,000 a fake pilot's license. So you can imagine that this isn't a joke. This is quite a scary and a pervasive problem. And the thing is that it's not easy to verify an academic certificate. A company usually needs to write a formal letter to the university, and due to, as we were discussing, GDPR, data protection regulations, the university needs to check, are they allowed to give out that information, before they can write back formally confirming that that certificate is real. So this can take weeks. And the fact is that normally only the higher education department in the UK found that only 20% of employers even ran proper checks on their employees. So how can blockchain technology help this? Well, let me first give a little overview of how would it work. So the university would issue their certificate, as it does now, and then publish this onto the blockchain. The student will receive that certificate as normal, no change for them, and they can provide that directly to the employer, and the employer can compare that to the record on the blockchain to confirm that it is indeed the original academic certificate. I'll give you more technical details in a bit. So what does this mean? What's happened here? Well, we've managed to remove the need for a central, trusted third party. So while before we were having to go directly to the university for this verification, now we can skip that part. So it doesn't matter if the university loses your records, they get damaged or stolen, or even if the university goes out of existence, we can still verify that that academic certificate is correct. Additionally, you have, I spoke about the diploma mills. They have this now added value service where they give you a phone number which the employer can call, which will pretend to be the registrar of the university and confirm your certificate is real. Once again, this removes this risk. We do not need to go to any other third party. But this only works if we know that the original data put on the blockchain has not been changed. And this is one of the core concepts of blockchain technology. It's an immutable ledger. So once something is put onto a blockchain, it is computationally impossible to change it. It is an unalterable document. So we can trust that when we compare the certificate which the student is providing to the employer to the blockchain record, we can trust that that blockchain, that original blockchain record, has not been manipulated. And as this is on public blockchains have the feature that they are completely transparent. So you can see all transactions which have occurred on the blockchain. And this, again, this aids There's no need to go to a third party. The employer can go direct to the source, to the blockchain. So we end up with a much quicker process, easy and quick to issue certificates and to reissue certificates, and also real-time verification. So the University of Nicosia, well, our background is that we are the leading educators in blockchain and digital currency education. We've been recognized by industry publications as #1 in the world. This includes our courses being recognized above Stanford, above Princeton, above Duke University. So we're extremely honored to be in this position. It was back in 2013 that we first started accepting Bitcoin as a tuition payment. In 2014, we started the first massive open online course, a free introduction to digital currencies, which has now had more than 20,000 students from 85 countries follow it. And we have the first and only, still only fully accredited masters in digital currency in the world. But it's not just education that a university wants to focus on. We also are committed to developing solutions and research in the area. So it was in 2015 that we first tested publishing certificates onto the blockchain. And since 2017, we have put all of the University of Nicosia's certificates onto the blockchain. That's all masters or doctorates or bachelors, over 5,000 certificates. So from there, we spun off the company Block.co, which has developed this system. So the point is for us to have an open, secure, decentralized, scalable self-verification solution. So when we were developing Block.co, there are a few key considerations we wanted to take into account. First of all, we wanted to embody the principles that are blockchain technology, the blockchain industry. So we made sure that the software we provide, the system we provide, is completely vendor independent. As I said, there is no reliance on the University of Nicosia or any other university for that matter. And this is surprisingly unusual in the blockchain field. We hear about all these startups and ICOs, and they've developed, some of them, fantastic decentralized peer-to-peer platforms, but ultimately they still have a central company which is controlling that platform, which decides what changes to the code happens, which accepts the customers, and if that company goes down, well, then you lose your supposedly decentralized system. In our solution, it's 100% open source, so both our code for issuing certificates and publishing on the blockchain, and our code for validating certificates is completely open source on GitHub, so anyone can use it, anyone can modify it, anyone can create their own validation service, and this is how we keep it independent from the university. And we wanted to make sure it's maximum ease of use. While blockchain is a great and exciting technology and the hype is here, the truth is we only know that blockchain has been successful when nobody cares about it anymore. We should be like with the internet, like with emails, we don't care what's happening in the background, we just want to be able to use it. So this is what Block.co tried to create. The student, they simply need to see the academic certificate, no different to normal, and for the employer, they upload this academic certificate to a validation service, which is just a web-based platform. So it's only the university issuing the certificate that needs to know anything about blockchain technology, or even that it's part of this. And finally, we wanted to create a platform-layered solution which integrates with other systems. Okay, so now I'm going to go into a bit more technical details on how have we actually achieved this? How are we actually managing to record our certificates on the blockchain? So as an overview, we start with the issuing of the certificate, PDF-based, onto the Bitcoin blockchain we use. We then have the validating software, so the employer's side where they can go and validate the certificate they've been provided with is accurate. And finally, where we need to revoke a certificate, remove a certificate, make changes to it, we have a solution for that as well. So let's take each one at a time. So let's start with how we issue a certificate. I'm going to get a little bit technical here. So we start with creating the simple PDF academic certificates. Okay, the same as you would normally see. And behind that, we put in two sets of metadata. Okay? The first set of metadata is essentially the information that the employer wants to check. The name of the candidate, what university they were at, what degree they were getting. Okay, so that's the first set of metadata. And then the second set of metadata is what links the certificate to the blockchain, in our case, the Bitcoin blockchain. So what's that metadata? Okay, so we use an algorithm to create what we call a hash value, which is like a digital fingerprint of the certificate. So you see the beginning of the number here, but it's a 64 alphanumeric string, which essentially represents that certificate. A bit like our fingerprint represents our DNA, this represents the certificate. Any small, tiny change to that certificate, a name change, a dot, a crossing, a grade change, would result in a different hash being created, and therefore it would be immediately easy to see, this was the original hash created from the original certificate. There's been an edit, so the hash has changed, and we can immediately see that something is wrong, and there has been a change on that certificate. Now, the hash is what we record on the blockchain in a Bitcoin transaction. However, it will be extremely inefficient to be doing a separate Bitcoin transaction for every single certificate we issue. So what we realize we need to do is start batching certificates. We don't just want to put one certificate on, we may want to put 1,000 certificates on at one time. And so what we do is we use something called a Merkle tree to essentially get a hash value which represents all those 1,000 certificates. So we start by creating the hash of each individual certificate, and then we do something called paired hashing. So we take two hashes from two certificates, and together we create a new hash. So this hash now represents those two certificates. We do this with another two certificates here and get a new hash. And we keep on doing this. So if we've got here I've got a tree of 4 certificates, but imagine 1,000 certificates. We keep on pairing these hashes until we get down to one final hash, which we call the Merkle root, which represents all those 1,000 certificates. So now we go back to our PDF, and in that second lot of metadata, we put in there the hash value of the original certificate, okay, to represent that one certificate. We put in this Merkle root, which is what is recorded onto the Bitcoin blockchain. So it's this bit of data which we actually put on the Bitcoin blockchain. Then we add in something called a Merkle proof. And essentially a Merkle proof, if you have the Merkle root and you have the proof, you are able to calculate backwards the individual hash values, which allows you to then compare, is the hash value on the Bitcoin blockchain the same as the certificate that's being created. And we also put on the Bitcoin transaction ID, so we can link it back to the Bitcoin blockchain. Okay, so that is how, technically, we put these academic certificates onto the blockchain. And I just want to express it. I keep on saying we put the certificates onto the blockchain. You see that we don't actually put that certificate, that data onto the blockchain. Because as we said, it's a transparent ledger, and you'd start having concerns about, okay, I don't want everyone to be able to see my certificate. The control lies with the students still. They can choose who they give their certificate to, but through this hashing, we can verify that the certificate they're giving has not been manipulated. So from the employer's point of view, they will receive the certificate, and they will go to a simple online validating service. And let me show you. So this is the University of Nicosia's online validating service, just a simple web platform. All they need to do is select a PDF file, the one that they've been given, and within a few seconds, it will communicate with the Bitcoin blockchain. And with a few seconds, we will get a reply saying this certificate is valid, or it's invalid, and we'll be able to see some of those key details, who the issuer is, the Bitcoin address of the issuer, so we know it came from the University of Nicosia, the names, the degree type, so the key information which the employer wants to verify. And we also have the transaction ID, so if we want, we can take that transaction ID, go to what we call a block explorer, and go and actually find in the Bitcoin blockchain that transaction. Now, I said before that one of the most important parts of this and a key concept in blockchain technology is immutability. It's the concept that we can't alter anything that's gone onto the blockchain. It's a permanent record. But what if we need to make a change to a certificate? What if we spelled someone's name wrong? What if a whole batch of certificates had an error in the grading system? So we needed to come up with a solution which would allow us to revoke a certificate. And this is really brand new research which is just being released now. And simply what we've done is we can't change the original transaction in the Bitcoin blockchain. So instead what we do is we create a new transaction which references back to that academic certificate and says this certificate has now been revoked. So while before the validating service you saw used to just go and get that one transaction and check the hash values, now it goes not only to that one transaction, but all future transactions on the Bitcoin blockchain and finds if there's any transactions which say that that certificate has later been revoked. So that's our solution for that. So what's our unique selling points? Simple. It's simple. You don't need to know blockchain technology. You need your PDF. You need your validating service. That is all you need. It's the most secure. We use the largest and therefore most secure blockchain technology there is, the Bitcoin blockchain, so, with its nodes. And finally, it is a really decentralized product. There is no reliance on the University of Nicosia or any other university to go back and verify. We have, as I said, the University of Nicosia has more than 5,000 certificates now on the blockchain. Also, we have the British University of Dubai, who in December 2017 issued over 1,000 certificates onto the blockchain. And the Dubai Police Academy, so starting to move away from the universities, is expected to release its first batch in 2018. And while this by itself is a huge, and so why our system adds so much value is it's an inexpensive system, cost to issue very simple and easy, and it's zero cost to validate, and very fast. It's a scalable solution. You may have heard a lot of problems with blockchain and scalability, but with the use of the Merkle tree and the Merkle roots, as I explained, you can have unlimited certificates uploaded into one Bitcoin transaction. The university is the market leaders in education technology, and we're experts, and this really is one of the few full-scale, real-life solutions available for blockchain applications. And finally, it's extensible. I have discussed academic certificates, how we can make sure that that original certificate is really the original one. But it could go beyond academic certificates. An easy next step would be to go to professional licenses, your license to practice law, your license to practice medicine. It could go to continuing professional education. These are, should we say, easier next steps, but it can go even further. We can go into civic records. We could have our birth certificates on there. We could have our death certificates. We could have marriage licenses. Okay, so we suddenly start being able to create a much richer pool of data, and this can all feed into this concept of a self-sovereign ID. Now we rely on governments to say who we are and to say whether essentially you can trust us. But with the blockchain solution, you can rely on the blockchain directly, and you can choose how you represent your identity. Plus, you can bring in it's not just going to be data silos of, the driving license authority has one bit of identity on you, Google has something else which says about your identity, the passport authority has something else. We can bring this all together to get a richer set of data on who we are, on who our identity is, and whether you can trust us. And we reduce the risk that we currently have now because the ownership of that data starts coming back to the individual, and we can decide who we give that information to, rather than leaving it with third parties, such as Facebook, who then, it's their duty to protect our data. So this is one of blockchain's core features, is to bring back that ownership of data to us as individuals so that we can protect our own identity. So thank you very much. So that is what we are doing on issuing academic certificates on the blockchain. Any questions?
So the whole idea of a blockchain solution is to be decentralized, is to have multiple nodes to keep the ledger. So you can be sure that something that you validate, it's truly validated.
Yeah.
If the University of Nicosia is the sole provider, how do you build a blockchain that is decentralized and not controlled only by one node, only by University of Nicosia?
So it's, first of all, the blockchain which we use is the Bitcoin blockchain. So it's not our own blockchain that we've created. So we have that benefit of all these thousands of nodes around the world verifying the transaction that goes on there. The element which is, shall we say, the University of Nicosia is the code which we have for creating this link to the Bitcoin blockchain. But this we keep completely open source, and anyone can access this and use it how it wants. And even then, even if we disappeared, if we that source code was no longer available, the point is that it's on the Bitcoin blockchain now, which has no reliance on the University of Nicosia, and therefore it really is decentralized because we could go directly peer-to-peer to the blockchain, not to the university. Okay. Anything else? Yes?
So if the credentials are being put on the Bitcoin blockchain, as we know now, Bitcoin is the most probable to be there in like 20, 50 years. But so if someone is putting their credentials there, there is that expectation, but we still can't guarantee that it will be there in 50 years or 30 years. And
I think we can't guarantee that it will still be one of the main blockchains. We can't guarantee that it will still be updated and the nodes will still be there validating transactions. But for our case, the validating part takes place when we issue onto the blockchain. The blockchain can exist by itself. That's the great thing about these. There is no central party. The code may not be updated. There may be no nodes still validating it. But the blockchain will still exist, and the history of the blockchain will still exist. So as long as, if the information's been put on there 10 years ago, we can still check it's still available. But you're right that going forward, you may need to change blockchains.
The problem is, right now, Bitcoin is the most secure blockchain, right? Because it's protected by so many nodes, and they have incentive to keep it the most secure. What I'm saying, if some other blockchain becomes bigger than Bitcoin and Bitcoin becomes smaller, but it's still there, then it's easier to attack it with 51 attacks and so on. So
you're right that I guess the risk is that I said that it's an immutable ledger and that computationally you can't change records on the ledger. But if there were there was two nodes, then they could go and change it. I guess the thing with Bitcoin is the further back the block is in the chain, the harder it is to manipulate that data because you need to change every single block. So we felt, you're right, it's very difficult to decide a solution now when the industry is growing.
It's the best solution
But we had to go with the solution that's available now, and given that still so many more transactions, and blocks are still being created every 10 minutes, and it does still seem to be the strongest, I think it would still be extremely hard to go back and manipulate the whole blockchain.
And if more solutions come for the Bitcoin blockchain, there's even more incentive to keep it
Yep.
being the largest.
And really, our solution is pretty flexible because we are simply putting metadata into the back of the PDF. So if we decided to use a different algorithm, a different hashing method to link to another blockchain, then we'll just change the metadata which is in our PDFs.
Okay, thank you.
Thank you.